The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to our new live webcast, A Safer Journey for Java Applications. Join us each month for new powerful messages, technical tips, and success stories that will leave you inspired and ready to get your protection, licensing, and security techniques another step closer to perfection. My name is Daniela Previtali, Global Marketing Director of WIBU-SYSTEMS, and I am delighted to have you here with us today. We are joined by Günther Fischer, Senior Consultant, Licensing and Protection, and Simon Kunz, Java Security Expert, both from the headquarters of WIBU-SYSTEMS. With today's session, we'll delve into the peculiarities of Java. Java is everywhere, and risks are lurking at every corner of the Java journey. To circumnavigate them, AxProtector Java comes with the ability to automatically encrypt the Java bytecode. It can only be decrypted on the fly during loading and before the Java virtual machine springs into action, and only if the right license is available. No decrypted bytecode will find its way onto the hardware during the entire process, and all hardware and software-based code meter license containers are supported. Some housekeeping we need to take care of before we start. For everyone who's joining us today, I want to remind you that we will be reserving some time at the end of the session for Q&A, and I'd like to invite you to submit any question you have in the live chat box. This session is being recorded, and a link to the replay will be posted directly to you in the next couple of days. And don't forget, stay with us throughout the live session for your chance to win an Amazon coupon worth €50. At the end of the webinar, a new tab in your browser with 3 simple quiz questions will show up. Unlike previous session, for those who have been following us for some time, you can now submit multiple choices for each question. We will draw the winner from among those who reply correctly and notify them at the time of the replay announcement. Please also note that the winner is excluded from all subsequent prize draws of 2018. Without further ado, I'll pass things over to Günther. The floor is yours.
Thank you, Daniela, for the nice introduction, and warm welcome here from lovely Karlsruhe from my side, and also from Simon, who is joining me to walk you through this session during the next 1 hour.
Yeah, welcome everybody, also from my side.
Hello, can you hear me?
Yes, now we can hear you, Günther. Thank you for coming back with us. I don't know what went wrong with our technical system, but I would recommend that you start from the very beginning.
Okay, so that's strange. So because we didn't change anything.
Yeah, I know.
So, okay, then let's repeat. So, my name is Günther, and together with my colleague Simon, I will talk to you and walk you through today's webinar.
Yeah, hello everybody. My name is Simon Kunz, and I welcome you to today's webinar.
So, in the beginning, we would like to give you a short overview of what is going to be the content of the webinar. So in the very beginning, we would like to remind you where Java comes from and what the special properties are and specialties are of Java as a language. Then we would also like to give you a short overview of what security technologies and protection technologies are used today to protect Java bytecode, to make it less readable for an attacker. And then we would like to move on and show some of the special functionalities that we've implemented in the AxProtector for Java. So as I said in the very beginning, Java was invented by Sun in the 90s. And the main idea was to implement a Java virtual machine as an abstract machine on top of a real physical hardware running on top on almost every OSs that are supporting the Java virtual machine. The Java compiler takes a class and it is compiling it into a Java bytecode. And then at the end, you typically deliver a jar file, which is basically a zip file with a manifest included. And then this jar file is executed on your virtual machine on the appropriate hardware and OS. The bytecode is, however, very easy to reverse engineer. But there is one special case that you need to keep in mind. Every time when a Java bytecode is executed, the Java virtual machine is loading the class completely from the hard disk and is running it then out of memory. So this is just another way to visualize this. So you have a Java source file, which is then compiled by the Java compiler. The Java compiler creates Java bytecode, which is the interpretation language, which is then interpreted on either Windows, where you have a virtual machine, Linux or Mac OS or whatever other OS you can think of. So this is where the acronym write once, run anywhere comes from. So the idea is you write the code once and you execute it without any modification on all of those different machines. So this is how it works. So you have a class file, which is then loaded by its class loader. In addition to your own application, there are class files that are provided together with the virtual machine itself. The class loader is loading all of this. Then the bytecode verifier is checking the consistency and if the bytecode is real bytecode, which is a regular bytecode, not any other code that might create a malfunction in the virtual machine. If all of this is positively defined, then the interpreter will execute the Java bytecode and your application is running on one of those different hardwares and OSs. In addition to the real Java bytecode, you can also extend the functionality to the Java virtual machine by using so-called Java native interface, which allows you to create your own extension to either the virtual machine or for your own application, which allows you to also bring some security into place by using native code instead of using the Java bytecode. So now let's go on with the different aspects of security for Java. So it is very easy, since the definition is publicly available of how a Java bytecode looks like, how a Java class looks like. It is very easy to extract Java bytecode and basically reverse it to its almost identical source code back to the Java implementation, so the Java source file basically. You can also replace parts of this and also modify it. So, which is basically allowing everybody to modify existing Java bytecode if it's not protected at all. So what are the different goals of software companies to protect their Java code? So one is, in the very beginning, it's about anti-piracy. So you would like to avoid that people are just copying your Java application and run it everywhere. So without having a valid license, which is one of the reasons. And another one is, which is the most important one, protected against reverse engineering. So as I said, it is very easy to do this reverse engineering part, and this is the main reason why really people are looking into protecting their IP. So the same is true for data that might come with the application. And in addition to what we provide with AxProtector, there is also an underlying runtime environment which allows you to encrypt and sign data that comes together with the application. So here is just a small summary of some of the applications that are available on the internet for people doing the reversing part. So even beginners can use those tools very easily and reverse engineer the source code. So this is just a small number of all the tools that exist, and we will see one in action almost at the end. In addition to the tools itself, there's also a lot of literature that allows you to read how to use the tools. And last but not least, there is also YouTube that will guide you in tutorial videos how to use the tools and how to reverse Java bytecode. So there are multiple options to try to protect your source code from being reverse engineered. The first one is obfuscation. And then there's another one which is basically against the original idea to have the code running on all the different machines, which is a Java to binary native code execution translator. And then if you use this approach, you can also use other things like AxProtector for native code to protect your application. But as I said, it is basically a contradiction to the original idea to have the code running on all the different machines and all the different operating systems. And then we come with the AxProtector. We also are able to really encrypt the Java bytecode, which makes it much more difficult for attackers to reverse the source code. And as I already said, there are other methods to protect, for example, additional data elements like recipes or machine logs together with the CodeMeter runtime that comes together with the AxProtector for Java. Here is a small selection of different tools that are available in the market to obfuscate Java bytecode. One very popular one is the ProGuard implementation because it's open source. And there are others like the Adatori, for example, or Classmaster that are available for commercial reasons. So you have to buy or purchase a license from them. As I said, there are others, for example, jar2exe to basically translate applications from Java bytecode to native binary, which are basically allowing you to use other protection mechanisms on the native code that is basically the end result of the translation. This is how this works. So you take your Java bytecode, the Java compiler basically creates Java bytecode, and then you take an additional tool to translate the Java bytecode into native code, which allows you to have an additional step at the end to create a protected binary, which is then a native binary. And one example how to do this is, for example, using the AxProtector for native environments. Now we want to come into the details and dive more into how AxProtector works and provides additional functionality over the ones that you have seen. And also doing this by allowing you to run this bytecode on all the different machines in the sense of write once, run everywhere. So first of all, you take the unprotected jar file, then you take the tool that's called AxProtector. AxProtector is automatically encrypting your binary, in this case, the Java bytecode, and then you need to have something that's called the AX engine to decrypt the bytecode when you start the application, and the AX engine will check for a valid license, and only if this valid license is available, it will do its work to decrypt the Java bytecode and then pass it on to the Java virtual machine. So this is done automatically, and you can see this in the file format. So a typical class has this header which contains the magic number called coffee babe, and this will be replaced by AxProtector to a different header which will be WIBU.com, and these are the protected Java bytecode binaries that are delivered to the customer, and the AxProtector will do this automatically for you. So AxProtector is supporting various versions of Java, starting with the 1.6 version till the Java 9 version. And it also supports different types of applications like real Java applications, applets or servlets. On the right-hand side, you see the selection when you start the AxProtector GUI, where you specify which type of application you're going to encrypt and protect. And as you can see, we selected a Java application in this case. And in addition to the protection mechanism in the jar file, the manifest file that is part of the jar file will be changed. And the main class will be replaced by the WIBU wrapper that is doing the extraction and decryption of the Java bytecode automatically for you while loading the application. So in addition, you can also manually add an entry point if you have an application that doesn't have a main class in itself. So by this, I would like to show you the AxProtector in action. So it's not only theoretical, so you can see how the functionality looks like. So I will use a Java Notepad clone to demonstrate how the functionality looks like. This is the AxProtector GUI, and then we selected a Java jar file that we are going to protect. Then we specify the type of license we would like to have being used by the customer that we provide them. In this case, this is the license for the whole jar file, so the whole application. And then we specify things that are common with all the AxProtectors, like the runtime settings. And then we come to the part that is specific for the Java implementation, for the AxProtector Java, which are the security options. And you will see after I've done this demo, all the different descriptions of all the different parameters here in this dialog. Then we come to the same thing as with all the other AxProtectors. You can have your own message handler, or you use the default message handler. In addition, you can also specify things that are specific for the Java VM, which are, for example, the version of Java that you're going to support, and so on. Additionally, we have something that's called AxProtector within AxProtector, which allows you to protect different classes with different licenses. And in this case, we have additionally to the main application, main class, a class that is allowing us to change the font. And this one is protected with a different license. So, and to do this, we have multiple ways how to specify which class is going to use which license. We have this graphical version of a browser that allows you to specify the different licenses to all the different classes. As you can see, the main application is protected automatically, and we have decided to use this font chooser class and use the different license, which is allowing us to use the font changing functionality of the Notepad clone. After you have all specified those different things, the AxProtector is creating an XML file for you that you can afterwards use in your build system to run this path automatically in your build environment. So by doing this, I'm going to protect my binary now, which is a jar file. And as you can see, it is just taking a couple of seconds. And now I have protected it. I'm going to show you how the unprotected version looks like. So this is what I'm going to start now. This is the unprotected version of the Java Notepad clone. So, and the application is always starting on my main screen, so I have to move it to the secondary screen so you can see it. And now I just finished this. I'm just starting the protected one. And as I said, the dialogues are appearing on my other screen, so I have to move it. Now you see the application is protected, and the application is requiring a license that allows me to use it. I'm going to connect a dongle which contains this license to it. And then I basically just say, okay, please retry. I have the valid license now. And after I did this, you can see the application is starting as previously. And now we go to this font class. And now we have a different license that's required, which is, as you have seen, a different one than the one that is protecting the overall jar file. And now I have to connect my second license, which is allowing me to run also this part of the application. And I do a retry. And now you can see that the font dialog is appearing. So far to how the functionality looks like. And now Simon is going to explain those parts that are specific to the Java security part in more details.
Yeah, thank you, Günther, for this very nice introduction. We will switch back to our slides. Thank you. So with the AxProtector, you are able to encrypt Java applications on class level and on method level, and there are some differences I want to explain to you. So if you encrypt on class level, then the whole class is encrypted as a whole. So as soon as your application needs the class, it is automatically decrypted by the AxProtector runtime and afterwards loaded by the JVM, by the Java virtual machine. You can absolutely do it in this way, but there are two things you should have in mind if you do that. First one is that only a single encryption key is used for the whole class, which means that you are not very flexible in terms of licensing. Second, as soon as a single method is used of your class, for instance, a small utility method, the whole class is encrypted and the whole class is loaded into the memory. So this is not necessary. And from a security point of view, this should be avoided. So for this reason, there is also the so-called encryption on method level, which is shown on the next slide. Yes. So what happens here is that each method of a class is extracted as a completely new class. So if you start up with 3 methods, then afterwards you will have 3 classes for each method. And the remaining class body contains only references to the newly created classes. This has 2 advantages. First one is that the methods are actually only loaded if really used. And the second advantage is that you can make a very flexible licensing system. So you can assign different licenses to the particular methods. And of course, you can also combine the encryption on class and on method level, which is shown here. So for instance, you can assign a basic license to the class body, which contains only the references, and each of your customers needs this basic license to run the application. And you can assign different feature-based licenses to the particular methods. So one method could be a separate feature for which the customer needs a license and thus needs to pay.
So you might ask, which different ways are existing to protect the code or the classes and the methods? And there are basically 3 flavors of it. So one you have already seen, which is the AxProtector GUI, which allows you to do this in a graphical way and by just decorating the class and method tree with all the different licenses. Another way is to use annotations in the source code. And otherwise, if you use it automatically in your build process, you typically would use the XML file that is created by AxProtector GUI at the end of the session. And you can also manually modify the XML file and extend it. So here's an example of how the annotation in the source code would look like. So the three most important annotations are protected, which allows you to assign a license, which is in this case done through a license list. So the license list index 0 basically is the first license that is applicable for the whole application. And then you have a license list 1, which would be in our example with the notepad, the second license we used to protect the font choosing class. In addition, you could also say, okay, this class should not be protected, or this method should not be protected. And if you have a jar file that doesn't have a main class, you can also manually define an entry point into your application so that external applications can refer to it, and the decryption would be done automatically for you. So in addition, that's what you have already seen. You have the possibility to do this in a graphical way by decorating this functionality in a class and message tree, and do this in a graphical way. And then at the end, as I said, the AxProtector is creating an XML file for you, which is a command line setting for the AxProtector, which would allow you to run this automatically into your build environment.
Okay, now we will have a closer look on some special features in AxProtector Java. For instance, you can insert traps into your Java application. Traps are against hacking attacks where a hacker might try to decrypt all your classes and methods by brute force techniques. And we define a trap as an encrypted class or method, and as soon as this trap is decrypted, the license is locked. So formally, the so-called firm access counter is set to 0, and only you as an ISV can unlock the license again. There are two ways to insert traps into Java applications. You can do it manually by yourself, or you can do it automatically by AxProtector Java. So you can use annotations in order to define certain methods in your application as a trap. And if you encrypt your application with AxProtector Java, this method is encrypted with a special key so that on decryption, the license can be locked. At the end, you will end up with an application where you cannot distinguish the real methods from the traps. And you should also reference your trap in your code, but you need to make sure that the traps are actually never called. Otherwise, yeah, the license is locked. And we suggest to use application logic. So for instance, if you work with taxes in your application, you could have a sample reference, like if the taxes are higher than 100%, call the trap. So which, of course, you know that this will never happen, but an attacker will not know that if it's really application dependent knowledge. You can also let AxProtector automatically insert traps in your application. So we have this option, it's -trap, and there you can give a number. It's 1 to 70 in this case. And this means that to approximately 70% of your methods, AxProtector Java will add encrypted traps. So if you have an application with 100 methods and you use the option like shown here, you end up with an application containing 170 methods, where 100 methods are your original methods and 70 methods are generated traps. Okay, so in the standard configuration, AxProtector Java only encrypts bytecode instructions. However, a class file consists of different sections, where also a constant pool is located, which are not encrypted. However, with a certain option, you can also encrypt the constant pool. So if you have constant pool entries of data types string, integer, and long, you can encrypt the constant pool entries of them. And they remain encrypted during the whole runtime of your program. And they are only decrypted on demand, on the fly. So as a very simplified example, we have a string, hello world, and after encrypted with the AxProtector Java enabled constant pool encryption, you end up with an encrypted string, which you can see here. And after that, we inserted a native function called to the AxProtector runtime, which decrypts this string again. And the special feature is that each time you run your application, the constant pool entries are differently encrypted. Another feature is the encryption of the method control flow. So as said before, if you use method encryption, each method of a class is extracted to a new class, and the remaining class body contains only references to the newly created classes. And with this option, you can encrypt the references to the extracted methods. So even if an attacker can get the unencrypted bytecode, he will not be able to follow your program flow just by reading. Then we have obfuscation, specifically obfuscation of names. So with AxProtector Java, you can apply obfuscation to class names, to method names, to field names, to package names, and to local variable names. You can individually control it, enable it, deactivate it for classes and methods, and you can apply it to encrypted and unencrypted classes and methods. On the right-hand side, there is a sample method which was encrypted, and in orange you can see class names, in blue you can see method names, in green you can see local variable names, and it is very, very hard to get some logic out of this obfuscated piece of code. Yeah, also you can enable and disable it via the AxProtector GUI, which is shown on the right-hand side. You can just right-click on classes and methods and enable the apply obfuscation button. Then there might be reasons where you do not want to encrypt your classes and methods, but you want to protect it from manipulation. So you can enable the integrity verification of class files, which means that if a class file was changed between the time of encryption and the runtime, well, the time you run your application, AxProtector will refuse to start. So if it's manipulated, you won't be able to start the application. And again, you can use it for classes and methods, and you can use it for encrypted and unencrypted classes and methods. Okay, now we come to code moving, which is a so-called high security feature. Code moving means that encrypted code is only decrypted and executed in the code meta dongle. So the encrypted code is transferred to the code meta dongle. It is decrypted inside this secure environment, executed in this secure environment, and only the result is transferred back to your method. There are some limitations. So for instance, you can only use it with universal firm code licenses, which were introduced in 2016. You can only use it with the newest code meta dongle generation, where the serial starts with a 3, and code meta ACT licenses, which are the software printout to code meta dongles. So these are pure software licenses, are not supported because it just makes no sense. And you can only use it locally, so not via LAN. And here I want to show you a small example of how code moving looks like. There is still one limitation, that the code moving code currently needs to be written in C. So on the left hand side, we have a Java method. It's supposed to add 2 integers, A and B. However, we have no real program logic in our Java code. We just return 0. So there is no logic in Java code. Instead, we have added an annotation called code moving, where a path is given to a C file named @integers.c, which you can see on the right-hand side. There you have basically two structs corresponding to the input and output parameters of the method, and you have a function called entry where the actual logic is implemented, specifically adding two integer values. So if you encrypt this piece of code, the Java code, with AxProtector, AxProtector will automatically remove the content of the original Java @integers method and will replace it by a code moving call, so that the code is executed in the code meta dongle. And this basic code moving is already supported by AxProtector Java, and we are currently working on an automatism so that Java code can be automatically translated into code which can be executed in the code meta dongle. Okay, so now we come to Java 9 support. As probably most of you know, last year in 2017, Java 9 was released by Oracle, and the probably biggest new feature was the introduction of the jigsaw module system, which means that each class of the JDK and JRE is associated to a module. And also the users of Java can create Java modules. These are jar files, so-called modular jar files, compared to classical jar files have an additional rights management. So this means that if you declare a class as a public class, this doesn't mean that it can be accessed from other modules necessarily. Instead, you have to provide or to adapt the rights management so that the public classes can be seen by other modules. And AxProtector Java already supports the encryption of these modular jars. So as an example, we have a module.jar. We protect it with AxProtector Java. We enable the corresponding checkbox to tell AxProtector that it's a module. And after protection, you will get an encrypted module. And additionally, you will get a WIBU runtime module, which is also a jigsaw module. And everything happens automatically, especially the rights management. So the dependency of the encrypted module to the WIBU runtime module is automatically adapted. And it doesn't matter how many modular jars you have. It is enough if you have only a single WIBU runtime module to run all your modular applications and jar files.
Now I would like to show you what we have just covered a little bit in the beginning, that there are a lot of tools that allow you to reverse engineer the code. So now you have seen how the AxProtector looks in action. So first of all, I would like to demonstrate one of the tools that allows you to reverse engineer your Java bytecode by just using the unencrypted version of Java Notepad that you have seen in the beginning. So when we go and open up the jar file, you can see the font chooser class that we encrypted with the AxProtector, which is basically allowing me to see the almost original source code. So you can see the reverse engineered version of the class file. In this case, this is the font chooser that I encrypted with a special license. And now I would like to show you how this looks like as soon as AxProtector was being used to protect it. I just take the protected version and do the same thing. So I go to the font chooser class, and you will see the code is completely gone. It is replaced by functions that allow us to execute the AxProtector engine to do the decryption as soon as the license is available. And you can also see we used obfuscation in this case. Some of the names are obfuscated. So this is one thing I wanted to show. Another thing is, as I said, you can also drive this by the XML format. So this is the XML file that was created by AxProtector Java for us, which allows me to use the same encryption to run this in the command line mode. And I also would like to show how this looks like in action. So I have prepared a command line environment, and I have a batch file that's just starting the protection. So, and by this, I'm just running the AxProtector in command line mode and using the XML file for configuration. As I said, this is an alternative, and it allows you to do this automatically in your build system. By this, we are reaching the end of our webinar and are open for questions now. Thank you very much. Do we have a question?
Yeah.
Okay, yeah. Do automatic traps contain bytecode?
Yeah, this is a good question. Yes. Yes, if AxProtector Java automatically creates traps, it adds also bytecode. There you need to know that the traps AxProtector Java creates are named the same as the original methods, but they are overloaded. So if you have a method which takes one integer variable, AxProtector Java may create a trap where two integer variables are given. And so the trap has a similar size than the original method.
There's another one.
There is also a question related, almost to the same topic. Should manual traps contain bytecode? Yes. You should fill manual traps with dummy code. So in my example with the method 3, with the annotation trap, it was a very simple example, but where it was no instruction basically. But you should definitely fill your manual traps with bytecode. Otherwise, an attacker could compare the sizes of the class files.
Oh, there's another one. Is it possible to obfuscate without encryption? Yes, definitely. You can also just obfuscate the Java bytecode, or in this case, Java source code, and then just use the obfuscation part of it.
Mm-hmm. Okay, we have another question. The question is which Java versions are currently supported, especially is Java 11 supported? The answer is no. Currently we support Java 1.6, 1.7, 1.8 and Java 9. Java 10 and 11 are not yet supported, and the reason is very simple. AxProtector Java also uses third-party libraries which do not support Java 11 yet. So we will do our best to support it as soon as possible.
Oh, there's a very common one. What is the impact of the security features on the performance?
Mm.
So,
yeah, I mean, security means you have to pay security with performance. So each security feature will slow down your application a bit. The question is how much it does. If you use AxProtector in the very standard configuration, no special features, we see a slowdown of 10 to 20%, which is okay for most of the applications. However, if you use some specific features I showed you, like the encryption of the constant pool or the encryption of the method control flow, it might slow down your application further. You should think about which security features you want to enable, and of course test it.
There's one more. How do I request
constant pool encryption? Can I use annotation? You can use the command line option. I think it's -CAA1. Or you can, in the AxProtector GUI, just enable the corresponding checkbox. However, you can currently only enable it globally. So at the moment, you're not able to activate it on particular classes.
So I think it was the last question. Okay, by this, we would like to thank you very much for taking the time to... No, there is another one.
Do most of the performance impacts happen on class loading or during runtime? This is also a very good question. Actually, class loading or the encryption before class loading, this is actually which takes about 10 to 20%. So it's relatively low, the impact. In fact, the highest impact comes from security features like constant pool encryption.
So there's one more now.
Mm-hmm.
So which version of the Java VM do we support? Is it Oracle or also OpenJDK?
Mm-hmm. Officially, AxProtector Java only supports Oracle Java. However, we are not aware of any problems using it together with OpenJDK.
So looks like this was the last question now, except somebody comes up with a new one. So if this is the case, I would again thank you very much for... No, there's another one. Okay, we could go on. So by this, so we would like to thank you very much for taking the time to listen to our webinar, and hope you have a great day, and good luck to win the Amazon Coupa, and thanks very much from our side.
Yeah, from my side also, thanks a lot for listening. Goodbye.
Goodbye.